Let's solve this question from GATE ECE 1993. A DC circuit shown in figure has a voltage source V, a current source I, and several resistors. A particular resistor R dissipates a power of 4 watts when V alone is active. The same resistor R dissipates a power of 9 watts when I alone is active. The power dissipated by R when both sources are active will be. So, the concept you need to know to solve this question is superposition theorem. Okay. After teaching you this concept, I will tell you how you identify to use superposition theorem for this problem. Alright, let's see. So I will write the equation and explain you what superposition theorem is. Now I have taken similar network. So what I want is I need voltage across VR which is equal to VV plus or minus Vi1 plus or minus Vi2. Okay, do you understand anything here? So the voltage across an element is equal to algebraic sum of voltages due to sources when they are acting alone. See, the voltage across VR is equal to voltage due to V1 when it is acting alone plus or minus voltage due to current source I1 when it is acting alone plus or minus voltage due to current source I2 when it is acting alone. What happens to the remaining sources? They will be nullified. The current source will be open circuited and voltage source will be short circuited. Here I is equal to 0, here V is equal to 0. Okay. So in the statement itself we are considering the sources are active alone. So the question, it is obvious that we need to use superposition theorem for this question, but how, that we will see. This applies same for current through the resistor R. IR is equal to IV plus or minus II1 plus or minus II2. So the total combined current through resistor R is equal to current due to V when it is acting alone plus or minus current I due to current source I1 when it is acting alone plus or minus current I due to current source I2 when it is acting alone. Now the question is when to use plus and when to use minus. I mean when to add and when to subtract. Actually in this problem we cannot comment, but if you know what is inside this circuit or this network, we can comment. If voltage sources are arranged like this, now I am traveling in this direction. You jump and look back, what you will see? We will see a positive sign. Let's say this is V1 and V2. We jump and we look back, what we see? So this is positive. And again we jump and we look back, what we see? We again see positive. So again plus V2. Here both V1 and V2 are supporting each other, so we will add these both voltages. If the voltage sources are like this, this is V1 and this is V2. We jump and we look back, what we see? A positive voltage. We jump and we look back, what we see? A negative voltage. Here they are opposing, so we are subtracting. And coming to currents, it is simple. If both currents are like this, they are supporting each other, we will simply add them. If currents are like this, they are opposing each other, and we will subtract them. Okay. Now coming to the question, they are asking about power dissipated by resistor R, but we did not see anything related to power till now. What we have seen is about voltage and current. We are doing algebraic sum of voltage and current because these are linear elements. We cannot do same thing for power because power is equal to V into I, which is equal to I square R, which is equal to V square by R. If you see carefully, we are having the square terms. If you increase I and V, the P is not increasing linearly. Okay, if you plot this graph, you will get a parabola. So this is not a linear term and we cannot do the algebraic sum. Now what we will do, let me write I as I is equal to square root of P by R. Substitute this in equation 1. What we will get, PR by R under root is equal to PV by R under root plus or minus PI1 by R under root plus or minus PI2 by R under root. The R in the denominator on both sides will get cancelled. Finally we will have PR is equal to PV under root plus or minus PI1 under root plus or minus PI2 under root. So no matter how many sources you have, this will continue. You keep on adding them. Okay. So this is the final formula. Now for our problem, a particular resistor R dissipates a power of 4 watts when V alone is active. When V alone is active, 4 watts is dissipated. Now I alone is active, 9 watts is dissipated. Now for our problem, PR is equal to, okay, this square root will go that side and we will have whole square. Okay. Now PR is equal to 4 under root plus or minus 9 under root whole square, which will give 25 watts and 1 watt. So if both sources are supporting each other, we will get 25 watts. If they are opposing each other, then we will get 1 watt. Okay. Based on the question, we need to decide, but here we cannot comment anything because we don't know anything related to that, because the network is a black box. Now let's see another thing. What if they have given energy due to voltage source V and EI? Then how to proceed? We need to find ER. Okay. We know E is equal to PT, E is equal to I square R into T, and from superposition theorem we have seen I total is equal to IV plus II. Okay, substitute this in here. So I total is equal to IV, take this as plus or minus II whole square into R into T. Expand this and we will get I square V plus or minus I square. Let's multiply RT also inside. I square V into RT plus or minus I square I into RT plus or minus 2IV II RT. So E total is equal to I square V RT plus or minus I square RT plus or minus, this I can change it as I square V RT into I square I RT. Since we know values of both of these, we can easily substitute. Okay. What I mean is, EV they have given some number, let's say 4, and this let's say 9, which is equal to I square V RT. This is equal to I square I RT. So we can directly substitute these EV and EI values here. This is simply like E total equal to EV plus or minus EI plus or minus 2 EV EI. This is the final formula. Okay. Now same formula for power is also available. P total is equal to PV plus or minus PI plus or minus 2 PV PI. Okay. Same derivation I will prove it. P is equal to I square R, right? Now I equal to IV plus or minus II. Just substitute here IV plus or minus II whole square into R. Expand it. You will get same result. You will get this result. Okay. I'm not going to expand it, it is taking more time. So you will get this result. These are the direct formulas. If you can remember, you can remember, or you can derive it in an exam. I suppose you not wrote on it, so derive it in the exam, because there are so many things you need to remember from all the subjects. So another important thing I want to mention is you only follow this method for DC circuits, not for AC circuits. Okay, there is different method to solve AC circuits, we will see later. Now using this superposition theorem, we are able to tell what is voltage, what is current, energy and power. This is all you need to know about superposition theorem. Thank you.